In the last lecture, we dealt with kinematic equations. We continue with the kinematic equations, but now we shall be taking motion in vertical direction. When we consider vertical direction, the first thing is to understand what is vertical. You see, you might find this question very easy, but many of the students are not able to answer this question. What is vertical? Remember that vertical direction is the direction towards the center of the earth, and it can be different at different places. I will show you the vertical directions at various places on the earth. You can see that at various places on the earth the vertical direction is different, but what is it? The vertical direction is the direction towards the center of the earth, that is called vertical direction, and the horizontal direction is just direction along the surface of the earth or perpendicular to the vertical direction. So, we define vertical direction first and then the horizontal direction. Another thing you must remember is that the acceleration due to gravity is always downwards, it is always vertically downwards towards the center of the earth. If a body is going up, the acceleration due to gravity is downwards, vertically downwards. If the body is moving down, even then the acceleration due to gravity is vertically downwards. If the body is moving sideways, even then the force on it is always towards the center of the earth, that the acceleration due to gravity is always towards the center of the earth or vertically downwards. Whatever the direction of the motion of the body, the direction of g is always towards the center of the earth or vertically downwards. For vertical motion, we take the same kinematic equations. All that we do is to replace a by g, the acceleration due to gravity, and we get these equations: v equal to u plus g t, s equal to u t plus half e g t square, and v square minus u square is 2 g s. Strategy to solve these problems is the same as we did earlier, it is not different. The value of g for most places on the earth is 9.8 meters per second square. However, to solve the problems here, to illustrate the problems here, we take g equal to 10 meter per second square. At this stage, we must note a few things. Unless specified, the air resistance is neglected. So, the motion of the body is free, no resistance of any kind. If an object is launched vertically upwards with velocity v, it arrives back at the launching point with the same velocity v. This is because of conservation of energy. When an object is going up, its velocity decreases because of g acting downwards. When the object is moving downwards, its velocity increases because g acts in the same direction as the direction of motion. Time of upward motion from any point equals that of downward motion up to that point. I will illustrate this in a moment. Here is a person standing on some building, throws a ball from point B to A. The time taken from B to A is the same as taken from A to B. Here is the same person not throwing, but letting the ball go downwards, releasing the ball at 0 velocity, and then the time taken from A to B is the same as it would take from B to A. That is because of conservation of energy. Let us take example 1. A ball is launched vertically upwards with a speed of 40 meters per second. What is its velocity at a height of 35 meters from the ground? How much time does it take to reach this height? Take g equal to 10 meters per second square. In this case, the initial speed is given as 40 meters per second. We need to find the speed at 35 meters height from the ground. So, we use v square minus u square is 2 g s, u is given, g is given. So, plugging these numbers, we get v equal to plus minus 30 meters per second. Again interesting, you get two results, plus minus 30 meters per second, and we have to choose very carefully the correct result. In this case, it happens that both the values are correct. V is equal to 30 meters per second, the velocity at 35 meters while going up, and v equal to minus 30 meters per second is the velocity while coming down after having reached the highest point. You see, the body was going up, it reaches 35 meters height, and then it keeps going, comes to rest, velocity becomes 0 and then starts moving downwards. The velocity is 30 seconds at this point, and while coming down at this point, the velocity is again 30 meters per second. The sign has changed because of the direction. In the first case, the velocity was upwards, in the second case, the velocity is downwards. So, this was positive, this is negative, but at the same height from the ground, the velocity is the same. The velocity is 30 seconds at this point, and while coming down at this point, the velocity is again 30 meters per second. The sign has changed because of the direction. In the first case, the velocity was upwards, in the second case, the velocity is downwards. So, this was positive, this is negative, but at the same height from the ground, the velocity is the same. The second part of the same problem, we have to find now the time. So, we use this equation S equal to u t plus half g t square, and since this is square in t, we get two values of t. In this case, if we put the numbers, we get t equal to 1 second and t equal to 7 seconds. Again, both these are correct. Why? 1 second is the time taken to reach the height 35 meters. Body is still going up, becomes has velocity 0 and then comes back and reaches this point again A at a height of 30 meters. This time from ground to the topmost point back to the point A, the time taken is 7 seconds. So, both the results are correct. T equal to 1 second while going up and t equal to 7 seconds while going up and then coming down to the same point A. So, in this case, both the times are correct, t equal to 1 second and t equal to 7 seconds. Let us take another example. This one example will illustrate ways in which equations of vertical motion are to be used. A rocket is fired vertically upwards. It is given an initial velocity of 80 meters per second and an upward acceleration of 4 meter per second square. When it has achieved a height of 1000 meters, its engines fail. So, we are asked how long does it take to reach 1000 meters, how high does the rocket eventually go, how long does it take for it to fall back to the earth, how long does it stay in the air, what is its velocity when it hits the ground. All these things can be found by using the three kinematic equations. So, let us start one by one. You see, it is very useful if we can sketch the problem given. So, I have tried to sketch this. The rocket is fired, it goes to a distance of 1000 meters on its engines, then the engines fail and then it continues, goes to a point where its velocity becomes 0. We shall find that this distance is 720 meters, and we shall then find out the time taken by it to reach back to the ground, given u equal to 0 and g equal to 10 meter per second square. So, let us solve point by point. Notice that the engines of the rocket provide enough upward thrust to give it an acceleration of 4 meter per second square. To find time in which the rocket reaches 1000 meters, the appropriate equation is S equal to u t plus half g t square. So, 1000 meters equal to 80 meters into t seconds plus half into 4 meters per second square into t second square. Let me also remind you that we are writing the units of each quantity along with it, so that we get the final units right. This is a good thing to do, and it is quadratic in t. The solution gives us t equal to minus 50 seconds or 10 seconds. It cannot be minus 50 seconds because the time starts from 0 when the rocket is fired. Therefore, we accept the answer 10 seconds. B. When the rocket reaches 1000 meters high, it has acquired an upward velocity given by v equal to u plus a t. So, we again use the numbers 80 meters per second plus 4 meter per second square into 10 seconds, and we get the velocity equal to 120 meters per second. That is, at a height of 1000 meters, the rocket has acquired a velocity equal to 120 meters per second. And now the engines fail. When the engines fail, then the rocket is in now free motion. That means, it is now being governed by the acceleration due to gravity. That is, the rocket now feels the acceleration of gravity downwards. First of all, we have to find how high it goes. When it reaches the topmost point, its velocity becomes 0 and initial velocity is 120 meters per second. G is 10 meters per second square with a minus sign, because the rocket is still going up and the acceleration is downwards. Therefore, we use this equation and get S equal to 720 meters. That is, from 1000 meters the rocket still goes up to a distance of 720 meters when its velocity becomes 0. So, the total distance covered by the rocket is 1000 plus 720, that is 1720 meters. Third point, the rocket has reached a height of 1720 meters where its velocity is 0. It starts its downward journey from a height of this 1720 meters with initial velocity 0. Since the acceleration due to gravity now is in the same direction as the motion, this value becomes positive. So, we use the relation S equal to u t plus half g t square, where S is 1720, u is 0, g is 10 meters per second square, and we get t turns out to be 18.5 seconds. So, it takes 18.5 seconds to come to the ground. To find the time for which the rocket was in the air, first we have to find the time for the rocket to reach 1000 meters, that was when the acceleration was 4 meter per second square. Then it goes up to 720 meters. We have to find time from this point to the time where it acquires 0 velocity, and then the total time coming down. If we find all these times using v equal to u minus g t, in all three cases we get the total time in air is 10 plus 12 plus 18.5, that is 40.5 seconds. So, the rocket in all takes 40.5 seconds. Let me illustrate this once again. You see, the rocket is going up at 1000 meter, it goes on its own engines, then the engines fail, it keeps going because it is at acquired certain velocity, goes 720 meters where its velocity becomes 0. So, in this part it takes 10 seconds, in the next part it takes 12 seconds, and then it takes 18.5 seconds to cover the total distance to the ground. So, that the total time taken is 40.5 seconds. For the final velocity when it reaches the ground, you have just to use v square minus u square equal to 2 g s, everything is known, and therefore, you get the velocity when it reaches the ground. It is 185.5 meter per second. A child playing on the roof of a building 20 meters high accidentally drops a paperweight. A person standing on the ground notices it. How much time does she have to move away and save herself from being hurt? This is a common problem. So, in this case, essentially we have to find the time the paperweight takes to reach the ground. So, at u is equal to 0, g equal to 10 meters per second square, and t we get as 2 seconds. So, if the person can move away in 2 seconds, she would be safe, otherwise she would be hurt. A ball is launched vertically upwards with a velocity of 30 meters per second. What is the time that the ball takes to return to its starting position? What is the velocity of the ball 5 seconds after being launched? What is the acceleration of the ball at its maximum height, and draw the graphs. At the highest point the velocity is 0, the body is going up, and at the highest point the velocity becomes 0. So, 0, then we use the equation v is equal to u minus g t, and we get the time is 3.1 seconds. And as we have discussed earlier, time to come down is also the same. For the velocity after 5 seconds, we get v equal to, again we use v equal to u minus g t, and we get the velocity as minus 19 meters per second. Why minus? See, in this case what happens is, the negative sign indicates that the ball is coming back after having reached the highest point. You see, the time 5 seconds is such that the ball goes up and comes down, and it is while it is coming down that we have got the that the velocity is minus 19 meters per second. So, you must be careful in this case. the ball goes up, reaches the highest point, comes back, and this time that we have the velocity that we have found minus 19 meters per second is the velocity when the body is coming down, not going up. At each point of its journey, including the highest point where it comes to rest momentarily, the ball experiences a downward acceleration equal to g. I have been emphasizing this all along, that acceleration due to gravity is always vertically downwards. And here are the graphs, they are simple, no problem. The acceleration here is constant, but minus, and the velocity, first of all it decreases, reaches 0, and then starts increasing and reaches again 30 meters per second, because the conservation of energy, it acquires the same velocity with which it was launched. Let us take another example. A ball is dropped vertically from a tower. If the vertical distance covered in the last second is equal to the distance covered in first 3 seconds, then find the height of the tower. Consider g equal to 10 meter per second square. In the last lecture, you remember, we derived this formula for the distance covered in nth second, that was S n equal to u plus half g into 2 n minus 1. So, we will use that formula. So, distance covered in 3 seconds is simply s equal to half g t square, it is 45 meters. Therefore, we use this formula now, half g is 5. So, 5 10 n minus 5, because n is 1. So, we get 10 n minus 5 is equal to 45 meters. In the last second, it covers the distance 10 n minus 5, and what is given is in the first 3 seconds it covers 45. Therefore, the equation is 10 n minus 5 is equal to 45, which gives n equal to 5 seconds. That is, the total journey time is 5 seconds, and the height of the tower is s equal to half into g into t, which is 125 meters. So, remember this formula, S n is equal to u plus half g into 2 n minus 1. So, if we substitute the values, you get 10 n minus 5, and this is equal to 45 from the condition of the problem. A ball is thrown vertically upwards from the ground with velocity u. While going up, it crosses a point A at a height 80 meters from the ground and returns to the same point after 6 seconds. You see, if you remember that from this point onward, the time is this, and it goes up and comes down, and the time taken is the same. If you know this, you can solve this problem easily. You can get the two values of t, and the two values of t are, one is for the ball to go to height A, and the other is for the ball to go up, get 0 velocity and then come down. So, the two values of t that you get, one is for this, another is for this and this. In this lecture, we have considered vertical motion. We have used kinematic equations to solve the problems concerning the vertical motion. But motion is not always in the vertical direction. For example, a cricketer hits a ball at an angle to the horizontal, and next time we shall try to find the path of that ball which is hit at an angle to the horizontal.